Hi, I'm Sumit. I'm going to talk to you about Slider. So I have been working in Slider for about a couple of months now, and before that I have been working on Ambari for about 1.5 years. So today I'm going to talk to you about Slider and then some aspect of integration of Slider into Ambari as well. So let me set up some context. It's should not be necessary. Today is the third day. So a lot of people have talked about how Yarn's evolution from like Hadoop 1 to Hadoop 2 and how it enables to become a multi-purpose platform. Essentially, Slider is a product of that thought process. So just consider this as a revision of what you have heard so far, and then I'm just going to go through it quickly. So this slide essentially establishes the fact that if you have some applications, let's say they were earlier not written as a Yarn application, you can actually migrate them to run on a Yarn platform. So the only slight change that I have here for my talk is that you could actually have an application that may or may not even use any of the Hadoop services. So let's say you can take Tomcat server or any application that doesn't necessarily interact directly with any of the Hadoop services. You can start to see that application that maybe can I host it using Yarn, and can I take advantage of some of the Yarn platform support that you may have and then host my application into Yarn. So Slider essentially comes from the idea that if I have some existing applications and I want to run them on Yarn, what do I have to do? So that's one of the motivation of Slider, and we will go through that in detail as I go ahead in my talk. So few of the advantages, just to reiterate. One, of course, if you want your application to be always on, then Yarn is your platform for you. If you want your application to behave in a flexible fashion, let's say there is an increase in load, you want to increase the number of slaves that are available, or there is a decrease in load, you want to reduce the footprint of your application or application instances while allowing other applications to take over and take advantage of available resources. So that's one flexibility that you can take advantage of being hosted on Yarn. And obviously, this whole thing happens because there is a notion of resource management, and essentially the applications delegate the resource management aspect of what compute you need and what other resources you may need back to Yarn, and then all the application is actually focusing on is getting activated and doing its actual job, which is interacting with external world in terms of what the application is actually doing without worrying about the resource optimization, resource management aspect of the application. So let's spend some time on long-lived application. So the focus of Slider is to actually look at long-lived applications, and if you run a long-lived application, what happens in the context of Yarn, and what can we do to make that this is actually easy. You can actually run a long-lived applications. So here is a very simple, think of it like a mental image of how you might want to see an application. Obviously, any application that you see is much, much more complex than, I don't know, 4 boxes plus 1 box on the outside. So think of the application as obviously a set of processes, right? I mean, that goes without saying. And these set of processes essentially tie up to what later we will call as component instances in Slider speak. So these are set of processes, and then processes obviously are communicating with each other. And of course, there are some external clients that want to talk to your component instances or application instances that is running within your data center. And of course, there are configurations that needs to be managed, because your application will start with, let's say, some base configuration. And then as time proceeds, you may want to reconfigure, you may want to change some configuration, you may want to optimize configuration. There might be a situation where some other dependent application might want to know what are some configuration this application is running as. So my goal for highlighting essentially the fact that there is a process, the process is trying to communicate with someone, and then there is a configuration will actually drive back into how Slider is trying to attack the problem. And as you can imagine, there are a lot of other aspects to an application, and Slider doesn't necessarily address all of them. So now let's go in detail as to what happens when an application runs for a long time. So if you have an application that comes up, does something interesting, goes down, there are a set of problems that you have to solve. But if the same application comes up and then let's say runs for months, maybe years, you have a different set of problems that come up and they become critical. So namely, one of the aspects is the management of the application. So now your application that is long-lived must be managed and must be managed well. So simple things like start, stop. You have to stop it and you have to start it for whatever reason. Obviously, you have to reconfigure. You have to scale up and down depending on the demand or depending on how much resource it consumes. You may have to do simple things like a rolling restart because you do not want your whole application to go down because you want to make some configuration changes or you may want to do some upgrade. So you may want to do a rolling restart of the application. And few other things that comes to mind is decommission and recommission, which are pretty often you will see in Hadoop services anyway. So now, in addition to that, if resources fail for a long-lived application, unlikely you are going to start from scratch. So that means if resource failure or if there is a downtime, they actually become a much, much larger concern. So for example, if you let's have a probability of, I don't know, less than 0.1% of failure, but if you look at that probability across, let's say, a year worth of run, then you do know that one fine day, that application may actually fail in a way that you won't really like it. So those are some of the concerns that becomes paramount when it is long-lived. And obviously, the other things like logs, and then how do you upgrade your application as time proceeds. You will definitely be much more interested in the metrics, whether it is the JMX or Ganglia metrics or whatnot. And then obviously, you have alerts. So to summarize, what I'm trying to say here is that as your application lives longer and longer, the management of the application becomes critical. So that feeds into some of our thinking in terms of what we are thinking as to working with Slider and how to create a Slider-based solution for the applications that are running on Yarn. So this is again something will be a repeat, rough idea of how an application runs on Yarn. So I will just quickly go through it. Just to touch upon some key aspects, obviously there is a resource manager, there is road manager, and then what happens is when you create an application with Yarn, there is some client that actually going to interact with the resource manager, allocate an application, and an application master comes up. And then once the application master is up, it will do its job, which is typically negotiating with the resource manager and asking for containers. And as the containers come up, inside the container, the logic of your application actually lives. So at this point, your application essentially becomes online. Now, in a simplistic term, something fails. So what happens? The failure is identified by Yarn. It informs the app master saying, hey, something failed. What do you want to do? The app master can decide to do anything, anywhere from, OK, give me one more container, and I am going to restart another instance of a component. So that summarizes how, in a very, very high level, a Yarn application might look like. Even in Slider context, it doesn't look much different. So the fundamentals of how a Yarn application will look will still remain the same. We are essentially trying to make it easier. So let's see. You have your long-lived application. You have the Yarn platform way of how an application works. And you are aware of the evolution of Yarn in terms of what features and capabilities it is providing for your application to work nicely on it. So what are the questions you will obviously ask? So these questions will be, these are the regular questions and nothing specific to Slider. So you will obviously, one of the questions you will ask is, do I have to rewrite my application? You do have a choice. You can rewrite your application and you can absorb the notion of app master into your application. And then you can obviously fit into the Yarn platform very nicely. So in fact, I will go later and talk about a Storm package for Slider. And then there is a parallel effort which is going on in terms of Storm on Yarn, where there is the research of how I can use the app master to actually have Storm run nicely on Yarn. Both are possible. So another question I would ask is, OK, how do I package my application? How do I hand off my application to Yarn? Is it RPM? Probably not. So that's definitely something you have to think about. Now that I have rewritten my application, or I made like very small change, I packaged my application. Okay, so I deploy my application. So obviously, I need to figure out how do I configure my application based on what are my needs in terms of how I want my application to perform. Obviously, debugging you have to do. You have to manage application, which is essentially what I talked about before, that if your application is up and running, you jump onto the next set of problems. How do I manage it? How do I ensure that it runs in a healthy fashion going forward? And few other things that you will ask is obviously, how do I monitor my application? Can I actually manage the dependency within the application, that is various component instances within applications, or whether the application actually depends on something else that is within its own boundary. And then naturally, how various clients will communicate with the application, and of course, how do I secure my application? Because if your application is deployed on a secure cluster, it needs to play well with respect to the security so that it actually runs within the context of a secured cluster. So our goal for Slider is to progressively answer all of these questions and then come up with an approach that actually works. Today, my goal is not to answer all of these questions. We are a fairly fresh project, about few months, and there is obviously some history before that. So I'm not going to answer all of the questions, but I will definitely try my best to explain whatever we have done so far and what we plan to do going forward. So in this context of the problem space, I'm going to introduce Slider. So if you think of writing applications on Yarn, there actually exist a number of projects. Slider is not the only one, and Slider is not going to be the last one. So the goal as far as Slider is concerned is essentially twofold. So one is, there exist a lot of applications that are already developed, what I am just calling as brownfield, perhaps line of business applications, that may or may not be completely using all the Hadoop services. Is there a way I can migrate them from how they are run today to run on Yarn in a cooperative fashion with all other applications that you have? The second part is, the goal is actually on Hadoop. So Hadoop clusters do exist. Obviously, there is data resources, there is compute resources. So the goal is, can we make it such that the compute resource gets well used, or the data resources or the data capacity gets well used across more applications? So essentially, it is reuse or better use of available resources on a Hadoop cluster, and especially focusing on existing applications. So that's the goal. Now, I'll spend some time on the history. So it started off as HBase on Yarn, and as the name suggests, the effort was to see what can I do to run HBase on Yarn, and one of the explicit goal was, can I actually do it without having to make any changes to HBase? So that's how it started, and then after that, migrated up to Accumulo and then Flume, etc., to see whether can I run all of these applications or services, the terms kind of gets interchanged, on Yarn. And then from there on, we moved on to one more level of indirection, where can I actually go to the extent where, as far as Yarn is concerned, the service and the application details are defined in a declarative fashion, and I actually use that to effectively run an application instance on my cluster. So that's where the Apache Slider actually currently is. So what are the various components of Slider? So one of the things that I want to impress on here is that if you look at the core structure, it is slightly different than a typical Yarn application. So essentially, I will highlight the differences. I mean, app master, it's pretty obvious. Anything that is running on Yarn, there is an app master in play. Whether the app master got written by the application author, or the app master is something that gets hidden because there is a framework or an infrastructure that provides the app master to you. But there is an app master, or the notion of app master, in play. As far as Slider is concerned, there is a notion of an agent provider. So the idea is this. So if you look at any container of an application that is activated through the Slider framework, then the container actually has a small footprint of what we call as the agent. And the agent actually is the one who knows how to interpret anything application specific or application-specific details that you may have. So the container, as far as Yarn is concerned, it is shared between an agent and actually the process that belongs to your application, so essentially the component instance. So together, the agent and the component instance define the container from Yarn perspective. So essentially, if the container is dead, means the agent as well as the process is dead. So that's the agent that sits in between, within the container along with your component instance. And the agent provider is essentially someone that sits in the app master and then talks to the agent. So as I go forward and then describe how application is defined, you will basically see how the agent behaves or what is the role of the agent with respect to interpreting the application definition. And then obviously there is a CLI is in terms of you need to interact with Yarn somehow, so that's the CLI. And then there is a registry. So the registry comes into play, it is fairly obvious. Again, this problem is not specific to Slider, so anytime you have your application, there is a dynamic notion of where the application comes up, where is the master running, which host, which port, so there is an obvious need of registry. For Slider, it is no different. And then there is a registry in play as well for this whole thing to work nicely. So what happens in summary? So you have your client, and then in your client, you specify something called an app package. We will go into detail for that. You specify an app package, and the app package is consumed by the client. It actually opens up the app package, reads some metadata from it. It actually identifies various components your application has, and you can also request how many instances of each component type that I need, et cetera, et cetera. And then it turns around and it does essentially what an Yarn application requires, which is request an app master. So once the app master instance is created, this is actually the Slider app master. So obviously, as you can imagine, we have abstracted out the role of app master and essentially created a common app master that will work for multiple application types. So once the app master comes up, it does its job of requesting the containers. The containers actually activate. The containers actually activate only with the agent. So the first step here when the container activates is that there is no notion of the application process or the component instance in the container. Only the agents come up. Oh, I have numbers, I forgot. Anyway, so the agents come up, and the agents actually register with the app master. So that means now the app master knows that the agent is active. That means a container is active. That means there is a space where I can actually instantiate the component instance. So now what the AM does is AM actually issues command to the agent, and namely, as far as Slider is concerned, the commands are install, configure, start, etc. So the commands actually go to the agent, and then agent executes the command. And when the agent executes command called install, it is basically laying out the bits for your application. When the agent is executing the command configure, it is basically taking configuration that is provided as input and ensuring the necessary site XMLs, etc., or env.sh and whatnot, they are properly modified to reflect the configuration. And then every command that the agent executes, it reports back the result, which AM actually records. And essentially, it has a simplistic state machine to allow for the application to go from installed, configured, start, and obviously stop, and et cetera, et cetera. And for some of the configuration that is late bound, so namely the host and port, et cetera, they are actually provided back to the app master, and they are reported back to the registry service so that it is available to the outside world who wants to communicate with the application. So let's spend some time on the Slider application package. You will notice that there is a huge similarity between this particular slide and the slide that was in the Ambari talk talking about the stack service description within Ambari. It is intentional. So the idea is that we use the same syntax or same format to describe a service that we do in Ambari as well as in Slider. So the idea is that application package essentially remains independent of what Slider does, but it's a self-contained entity with respect to defining what the application actually is and what application commands are. so that the package is basically portable. It can be consumed by Slider, it can be consumed by Ambari, it can be consumed by any management infrastructure that actually wishes to, let's say, integrate with the Slider infrastructure. So this is very intentional overlap, that the Slider application specification looks very similar to Ambari's service specification. So this is a very high level structure. I'm just going to highlight few things. So as you can see, there is a default configuration that is captured in the package, which tells you what are my default configuration for the applications are. And then in the package, I have various things such as files, scripts, templates, and then there are a bunch of JSON files that are capturing things like what are my key JMX metrics, what are my ganglia metrics, et cetera, et cetera. So as you go, let's say, one level deep into the metainfo.xml, this is the file that binds the whole of the package together. So this particular file describes what my application is, what are the members of my application. So in this case, Storm Nimbus happens to be a component of Storm, and then where exactly the intelligence of all the commands that will be executed when I start Nimbus or I configure Nimbus or I install Nimbus, where they live. So essentially, there is a Python file that's actually sitting there. And there are some default commands which is required from every application, but you can define your custom commands. For example, if you had decommission, it's actually a custom command that you can add. So essentially, the idea is this metainfo.xml file is self-contained as well as extensible, so you can extend it based on the need of your own application. So going further deep into the package structure, the package structure actually has three things. So there are files, which are generally any file that you may need for your application to run. In this case, there is a tarball that you see here, which is the Storm tarball, which essentially saying the application package is nothing but a layer on top of the actual Storm implementation or Storm bits that you have. And then you have a bunch of scripts, and from the name of the scripts, I'm pretty sure it's fairly obvious to you what the scripts are doing. They essentially hold the logic of what would happen if I want to configure, install, and start various components of my application. And then there are some templates which are essentially just special in the sense that the file can actually be replaced. The template file can be filled in based on the configuration as needed. So, and the final one that I wanted to highlight here is, if you look at an individual script, it's basically a set of functions. And the functions are nothing but the commands. So that means what's going on here is that if you start to build it from ground up, you basically look at, okay, in order to manage my application, what I need. Obviously, you need start, stop, install, and things like that. Then you capture the logic of what needs to be done within a function, and then you package that all up together to become a components definition. You package that all up together to become your application definition, and you add some extra stuff around to make sure it fits into how Slider actually consumes the application package. So this is going into the meta info. There are a few things that I wanted to highlight here. I mean, obviously, you need to put the name of your application somewhere. But there are few extra aspects in the meta info that we have added that you may need to say, I want to export in URI. So for example, if your application actually has a JMX endpoint, then you want to export the JMX endpoint for obvious reasons, you can actually specify that in the meta info. So what Slider will do is it will read in the configuration, for example, for the JMX endpoint while the application is activated, and then publish it back to what you call the registry, so that this JMX endpoint is available for you to take a look at. And similarly, other things that you can actually define some sort of command order. We are essentially evolving the structure to make sure it is actually powerful enough without being overly complex to specify various nuances of how your application starts. But then the idea is metainfo is the place where this whole thing is kept. There are two other files that come into play when you actually run something using Slider. So one is the resource spec. As the name suggests, this is where you capture everything, all the resource requirement that you have from Yarn. And then another file is the configuration spec, which is essentially a configuration of your application, which is captured in the app config.json. These become the input to Slider. So this is actually a video of using Slider through the command line. And as you can see, I have installed Slider, which is just a tarball that you just expand. And then you just configure it a bit so that it actually works against the yarn cluster that you have. So in this particular example, I'm creating an instance of Accumulo. So if I look into the resource.json for Accumulo, you can actually see various components of Accumulo, which is the monitor, tserver, GC, etc. And similarly, if you look into the app config.json for that Accumulo application instance, you will actually see various configuration required by Accumulo, and namely the key ones being that there is a configuration which requires you to allocate a port and then report it back to the registry service, which happens to be the Accumulo monitoring service. So what I do now is I just create an Accumulo instance, which is essentially telling Slider that, okay, here is the resource.json, here is my app config.json, here is the tarball which actually packages the whole Accumulo detail, and go ahead and start it in yarn. So that's exactly what happened through Slider. In Slider, there is no service, it's just a command line. And this application actually comes up, and you can see it in the traditional way by going to yarn and then looking up for applications. So this is the Accumulo AIM tracking UI. And then we have actually added few extra information here to essentially give you a glimpse of what exactly the app instance consists of. But this is just an example of going to, for example, the quick links, which is for Accumulo. Let's say I think we just published the monitoring UI for the Accumulo. And then as you can see, it actually has a port number that is allocated dynamically by Slider. And that is what is published in the registry, which you can use to access your monitoring endpoint. Now, as Accumulo is running from the yarn context, we'll just spend a minute or two looking into the various processes that comes up. This is actually a single node VM because I wanted to see all the processes in a single machine anyway. So if you look into the Python processes, these are the agents that are running. So you will see one agent instance for every component instance that you bring up. And the yarn container layout is basically used so that the application has a place where they can emit their logs, the agents can emit their log. So and then the various commands that you execute using agent, they can emit their logs. So these logs can be found in the usual place where the yarn actually places their logs. And then let's just take a look at various logs that gets used. So that essentially gives you an idea of what is the layout. So basically you allocate a container, and then you start the application, and there is room given for the application to emit various logs, the agent to emit the logs, so that you can use it to essentially debug your application as needed. And then this essentially summarizes how your application looks when you go deep into one instance of a container and then look through the footprint of the container, namely the processes and the various files that got created. So before I jump onto the Slider integration into Ambari, here's just one splash slide on application registry. So as I said, the registry is not necessarily a problem for Slider. It's a common problem across any application that runs on yarn. So from Slider perspective, our goal is to actually integrate with an application registry that is actually core to yarn. And then that is essentially being worked on. There are a couple of Jiras out to capture this effort. So from Slider side, it will be integrated into the application registry from the yarn side. So, but currently what we have today, because I did show you a registry which is essentially we took Apache Curator based registry and then embed that into the AIM of a Slider instantiated application so that it is available for any clients or someone else to consume. So now let's move on to the Slider view for Ambari. So in the Ambari talk, we actually talked about there is an effort in Ambari to create ability for you to create views that gets embedded into Ambari. So what happened was that Srimant from Ambari essentially worked through to create a view that is actually for Slider. So if you look at a very high level, what's going on here is that you actually have the Ambari front end where there is a view UI exists. There is a view backend that sits into the Ambari server, and the view backend actually integrates with Slider to provide you a management infrastructure, if you will, for slider applications. So this is another demo, couple of minutes, that actually is demo of the view that is hosted in Ambari itself. So at the start, you can actually see the Accumulo instance that I had created on the command line. So essentially, the view just got the Accumulo instance, and then the instance is actually frozen. So in this particular example, what we are seeing here is creation of a view for HBase. And you can go through the necessary configuration steps where you can modify the resource requirement. I actually just went down on the resource requirement because they are all in the single cluster. And you can edit your configuration, etc., to make the changes as needed so that this view, this particular application instance works for your cluster. Because we are going to show you the integration with Ganglia, that is the only change that I did from the default configuration, because the Ganglia server was on a specific host name, and that's the only change that I did here. Everything else, the default configuration actually works fine. You don't have to change, at least from a demo perspective, you don't have to change. So what really happened was that you went through all the steps, you made all the config changes, and the HBase instance actually came up. And this is what you see from the view, a summary of the HBase application instance. So what you see here is the various component instances that are up now for this particular application. There is a summary from the JMX endpoint, which is actually the JMX endpoint that Slider published, and then the view actually reads the JMX endpoint and gets all the data out. And you also saw the Ganglia metrics, which is essentially the same thing. The application publishes the Ganglia endpoint, and the view actually uses the Ganglia endpoint to get all the metrics out and then display it in the view. And of course, you can have access to all the configurations, namely the configuration that is actually applied when the application got started. So it's not the default configuration you started with, it's actually the configuration that has been filled in with the actual host and port. So from the view perspective, essentially it is showing you what's going on inside the application when the application is up and running. And these are some of the quick links, which is the JMX and the metrics and the UI, etc. So let's go on to the HBase UI, which is the HBase master UI, and then you are familiar with it. I had run this application a few times, which is the reason why there are some dead region servers. But this is the HBase UI as you can get from the published information of the application. So there are a few other quick links, namely Ganglia, and then you can actually go to the Ganglia web server. There is no magic here. Essentially, the application said that I want to publish my Ganglia endpoint. Here is the URL structure. Fill in the details that you know when you activate the application, and then make it available to an end user in terms of when they actually look into the view to look for the instance of this application. So you can do few operations through the view, which is essentially supported by Slider. So this is an example of doing a flex, which is actually you want to increase, let's say, number of instances of the HBase region server, and then you go to the view, it actually turns around, talks to Slider, and then issues the command where essentially a container comes up, and then you can actually see a second instance of HBase. So while that instance actually warms up and then it registers with HBase master, let's spend some time on the Storm side of the view. So what I did was that I also instantiated a Storm instance on the same cluster. So this is actually Storm and HBase running on a 3-node cluster that I used. And you can see exactly the same thing here. There is a JMX detail, there are some Ganglia metrics, and then of course the Storm UI that you can go and then see what do you call, I think I had created one topology for word count, which is what I shall feed in the Ganglia metrics as well. So as you can see, there is a very normalized view of Storm, HBase, and similarly, if I had my active Accumulo instance, you can access through the view. So the goal of this view was to basically integrate with Slider from Ambari such that you can essentially see a very similar management experience as you can see if, let's say, HBase was deployed by Ambari first class. So it is very intentional, again, that you do not see any difference between what you would see if you go to HBase that is deployed by Ambari or HBase that was deployed by Slider, and then there is a view in Ambari to actually go through all the details of HBase. And as you can see now, the second instance actually came up, and then it registered with master, and then that's basically the summary of the view. And it is completely integrated into Ambari exactly the same way as any other view gets integrated into Ambari. So let me spend some time on what is sort of comes into future, and essentially the slider allows for it, but with the view we didn't exactly integrate completely. So the idea is that because I told you initially that there is an agent that sits in every container instance, and the agent actually registers with what you call the app master, and the app master issues command. What it allows you to do is you can have your agent register with any management infrastructure you want, and then essentially the infrastructure can actually be Ambari. So that means from Ambari perspective, if the agent actually registers with Ambari and is open to take in commands and then provide reports of what happens, the experience you will see will be very similar to what you see in Ambari today. Now, it can be any management infrastructure as long as it can issue commands like install, start, stop, configure, etc. So all you need is the command and the details, and the agent will actually do the job. So the goal, our goal out here is that if you use Slider to essentially start your application, you have the full ability to manage your application instance any which way you want. You are not limited by what Slider actually does internally in terms of what commands it understands. So to close, like I said, this is a fairly new project. So, and then like I said, my goal was not to answer all of the questions. So as you can see, some of the questions that I put in the beginning are actually still here, essentially talking about what we are trying to do. So obviously we need to lock in the application specification so that it doesn't change much. And if you create an application package that remains true through various versions of Slider, we are not there yet. And the obvious next things are like integration with registry, security, need to improve debugging. We need to be more robust about failure handling. If anything fails, whether it's node manager, resource manager, or there's a resource manager HA, etc., the Slider has to work along with that. And finally, these are some of the links. And then obviously, open source Apache project. So you're welcome to contribute. We would love that. And thanks a lot. Questions? Yeah.
So, if there are partially executed jobs, tasks,
Yeah.
and if there is a failure in the middle of, let's say, container is doing whatever it's doing, and it requires additional resources and whatnot, bottom line is, your map already is partially done. So, who tracks the completion of the job?
So the question was about if you had mappers and reducers that are, let's say, partially complete. So the thing is, the MapReduce is actually a core Yarn application. So if you look at MapReduce support today in HTTP2, so there is an app master, or what you call as the job tracker, and that takes care of what to do if there are failures. So the application specific logic, if it's such that it needs to react to failures, then the app master has to know how to deal with it. Now, for example, if you come into HBase and let's say region server fails, which is, I mean, it happens, and then if it is running through Slider and then a new instance of the region server comes in, then there is logic in HBase to essentially take care of that, move the region around and whatnot. So yeah, it doesn't necessarily fall into the scope of Slider, how to fix that. And that's again intentional. So there is an expectation that the application actually is fairly self-contained in its own. Because you see, the goal is that we are looking at brownfield application. That means the application actually worked fairly well before or without Yarn. It will still continue to do so. We will essentially provide the layers necessary to make it easier for the application to adapt to how Yarn actually views resources. So, yeah. Yeah.
The details of
right.
what's going on the container, and probably may not even see the results of it.
Oh, next. Oh, okay. Oh, sorry. I'll get back to you. Yeah. Yeah, sorry. Yeah.
So there's surely some overlap between Slider and Docker in the sense like the application specification management, packaging of an app.
Yeah.
And I've been hearing in other
Yes.
So I'm just thinking about like why is that separate? Like
So,
sliders.
yeah, I mean, you're right. In fact, it doesn't even stop there. I think I was talking to Matt from Red Hat, and there is a notion of a cartridge, how to specify an application for Linux as well. So there are, the thing is, our goal is definitely to come up with a specification, and then if there are any common, what do you call, schema that can be reused, we are completely open to actually switching over to the schema, because the schema doesn't really matter much. It's the content. But at least so far, we haven't come across a standard schema of specifying an application that actually fits nicely. But we are definitely open to that idea. And then if you look at Slider, it is the agent provider that understands the schema. So it's actually not part of the core Slider in the sense of the core logic yet. So it is really pluggable. And then we'll definitely happy to stick to some common schema, because our goal is to make the application package as portable as possible so that anybody can actually consume it. I might have